Okay, ladies and gentlemen, this is concept 33, which deals with systems of equations word problems. Now, the cool thing is that it's very similar and some ways identical to concept 32, where we're solving systems of equations, but we just start with the word problem and have to translate the words into symbols and numbers. So that's what we're going to be focusing on in this lesson. Um, So to translate the words into a system of equations, first, we need to ask ourselves what two quantities are given, and once we know what those are, we assign variables to them. So usually when they ask a question in the problem, that tells us what we're looking for, and those are going to be what the variables are. And once we know what the variables are, and we look at the other conditions in the problem, we can write equations. And the equations are going to look like systems of equations. So here's a few steps here. Our first step is to just read the problem, and we're going to underline or highlight the question. We're going to define the variables we're looking for, and then we're going to write equations using the information given in the problem. And then we would go about solving the equations, the system of equations, and then we would state our solution in the end. So again, in this video, I'm going to focus on setting up the equations and translating them from words to mathematical language. And the reason is because the solving is just like concept 32. It's the same thing. So that's what we'll focus on in this video. So let's take a look at our first example. It says that Jorge's school is selling tickets to the spring musical. On the first day of ticket sales, the school sold 3 adult tickets and 9 student tickets for a total of $75. And the school took in $67 on the second day by selling 8 adult tickets and 5 student tickets. So what is the price of one adult ticket and one student ticket? So in that question, it asks us two things, the price of one adult ticket and the price of one student ticket. Those are going to be our variables. So I said that A is going to be the price of an adult ticket and S is the price of a student ticket. I underlined those in different colors because we'll look at that information in the problem later on. So I created a table here to help us organize our information because we're given 3 bits of information. We're given the adult tickets, student tickets, and then totals, like total cost. Um, so uh, in this scenario, it tells us that on the first day, we sold 3 adult tickets, which is underlined in blue, and we sold 9 student tickets, which is underlined in red, for the first day. And we made a total of $75. And what we can do is we can start to build equations. So on the first day, we sold 3 adult tickets, or 3 A's. 3 A's. And on the second day, we sold 9 student tickets, or 9S. And on the third day, we made a total of $75. And on the second day, we sold 8 adult tickets, and we sold 5 student tickets for a total of $67. Now, now that we have this information, this tells us what our equations are. I just put a plus in here and equal signs here. Well, those are my equations. And normally when I'm doing this problem, or these types of problems, I would just go about solving. I would write them out. 3A plus 9S is equal to 75. And 8 adult tickets plus 5 student tickets gives me $67. And I would go about, solving the equations to get them to what they need to be. Like, I would make this 8 maybe, and maybe this -3 to get it to cancel out, and you would go about solving it like you normally would. But again, I'm not going to solve that in this video. Go ahead and look back at the previous videos for examples. So that's that. just translating the language into mathematical symbols. Let's take a look at another example. If I have a hotel that has 150 rooms and some have kitchens, and the ones that with kitchens are rent for $100 a night, and when they don't have a kitchen, they rent for $80 per night. So on a night when the hotel was completely occupied, where every room was filled, revenues or profits for the hotel were $13,000. So they made $13,000 when they filled up every room. So we want to find out how many of each type of room does the hotel have. So we're asked the types of rooms. So some have kitchens, some don't. So if I said X is the number of rooms with kitchens, and Y is the number of rooms without kitchens. So we're given two bits of information. We're given two totals. We know that the hotel has 150 rooms total, and that 150 means some that were with kitchens and some without kitchens. Now we don't know how many, but we know that the number of rooms with kitchens is X, and the number of rooms without kitchens is Y. We don't know how many, so we leave it as X and Y. Now we're also told that the total amount of money that is earned by the hotel, or the revenues, is $13,000 when they fill up all the rooms. And we're told that rooms with kitchens cost $100 per night. So we could say 100 times X, because the hotel gets $100 for every room with a kitchen. Similarly, the hotel gets $80 for every room that does not have a kitchen, or 80Y. So again, we can write them this way, and we can turn them into equations. So X plus Y is equal to 150. That represents the total number of rooms, and 100X plus 80Y gives us 13,000, which is the cost, the total amount of money that the hotel earns. So hopefully these two problems give you some idea of how to set them up. We'll do one more as practice, and then I think it'll be good. So if a test has 20 questions and they're worth 100 points, and the test consists of true or false questions worth 3 points and multiple choice questions worth 11 points. So we want to know how many multiple choice questions there are. So in order for us to do that, we have to, again, define our variables. If I said X is the number of true and false questions, X is the number of true and false questions, and Y is the number of multiple choice questions. So that's what we're looking for, right? So the number of true and false, the number of true and false, and we're looking for the number of multiple choice. And then we're also given totals. So we know two things. We know that the test has 20 questions and is worth 100 points. So if I'm looking at the number of questions and number of points, this gives me something very specific, and I can write equations for this. So I know that I have 20 questions total and 100 points total. Now, similar to the previous problem that told us the number of rooms, the types of rooms, well, we have two types of questions. We have X's, which are true and false questions, and we have y's, which are multiple choice questions. We don't know how many we have. It could be 15 true and false and 5 multiple choice. It could be 7 true and false and 13 multiple choice, but total, they're going to add up to 20. If we also look at the multiple choice questions, we know that, or sorry, if we look at the number of points, we can see that 3 points come from each true and false question, and 11 points come from each multiple choice question. So in other words, we could say that to find the total number of points coming from true and false questions, we would take 3 times x, right? So each multiple choice, each true and false question has 3 points each, so 3 times x. And we have multiple choice questions, which are 11 points each, so 11y. So then again, we came up with an equation, right? X plus y is equal to 20, and 3x plus 3y is equal to 100. We would write out those and solve them like we would, right? Maybe multiply the top one by -3, so then the x's cancel out, and then you finish it out. You can find out what is x and what is y, and that'll give you your answer. And that's it. That's all for concept 33.